Imagine having not one but a whole team of AI agents that can think, collaborate and improve themselves, all without you lifting a finger. Today, you will see how we go from a simple single agent setup to a powerful multi-agent system. And by the end, you will know exactly how to build your own. We will start with a single CAMEL AI agent, a focused, specialized system designed to handle customer order inquiries. Our goal is to build an agent that can quickly retrieve an order's status, customer details, and payment information, while maintaining a polite and consistent response style. Before we begin, here is the CSV file our agent will work with. It contains 4 columns: order ID, customer name, status, and total. This structured dataset will act as our knowledge base, ensuring the agent can give precise answers to customer queries. The first step is to load our order data from the CSV file into memory. This gives the agent immediate access to all records without querying an external database. We are using pandas here for its efficiency in handling tabular data, but the same logic could work with any structured data source. Next, we define a lookup function. This function accepts an order number as input, searches the dataset, and returns the relevant details. If the order exists, we include all columns in the response: order ID, customer name, payment status, and total amount. If it does not, the function returns a clear, consistent error message, so the customer is never left wondering what went wrong. Now we configure our CAMEL AI API client. We select the GPT-4 model for high-quality language understanding and set parameters for reproducibility, such as temperature and token limits. This step ensures our agent is stable, predictable, and does not produce overly random or inconsistent responses. Once our lookup function is ready, we wrap it in a function tool, the standard way to expose custom functions to a CAMEL AI agent. This allows the agent to call the function on demand, exactly when it detects a request for order details. For a deep dive into function tools, see our detailed tutorial video linked in the top left corner of the screen.
With the tool ready, we instantiate our customer support agent. We clearly define its role: detect when the customer provides or requests an order number, call the lookup tool to retrieve details, respond politely, clearly, and with only the necessary information. This role definition ensures the agent stays on task and never drifts into unrelated topics. Now we create a dedicated chat with customer function. This is where the magic happens. It takes a customer's message, sends it to our agent, captures the response, and neatly prints the conversation. This function will act as our bridge between the customer and the AI agent. We add a short main block to call our chat with customer function. This is where the conversation actually comes to life. Now, we test with a valid order ID and an invalid one, confirming the agent can both deliver accurate results and handle errors gracefully. First, a valid order number, where the agent quickly pulls the details from our CSV and responds in a professional, friendly tone. Then, an order number that does not exist, where the agent politely explains the issue and suggests checking the order number. At this stage, our single agent setup works smoothly, handles errors gracefully, and delivers a realistic support experience. Up next, we will look at why multiple agents matter, exploring real use cases and return on investment. Then, best practices for collaboration, and finally, how to refactor this into a full multi-agent workflow. Now, why even consider multiple agents? Because real-world problems are rarely solved by a single perspective. Students use agents to quickly gather facts and organize study material. Businesses rely on agents to track orders, manage support tickets, and streamline operations. Creators leverage agents to brainstorm ideas, repurpose scripts, and manage publishing schedules. One well-designed agent saves hours, but a team, that is exponential productivity. Before we expand, 3 golden rules keep your AI team from turning into chaos. 1. Define each role clearly. 2. Control communication channels. 3. Track progress and outputs. Follow these and your agents do not just work, they thrive. Our single agent chatbot works great for simple order lookups. But what if the customer is angry or needs an escalation? Or if we want to separate back-end logic from polite responses? A single agent cannot handle all these roles well. That is why we introduce a multi-agent workflow, where each agent has one job, and together they collaborate just like a real support team. In this setup, not every task needs the full power of GPT-4. We use GPT 3.5 for back-end data lookups and supervisor responses, since those are cheaper and more mechanical. And we reserve GPT-4 for the frontline customer service agent, where high-quality language really matters. This balance keeps our system both cost, efficient, and high quality.
Next, we split responsibilities across 3 specialized agents. The database agent, a back-end system that strictly returns raw order details, nothing more. The supervisor agent, called only when a customer is upset, ensuring empathy and escalation. The customer service agent, the front line talking directly to customers. It decides whether to query an order, escalate, or simply reply. Each agent has its own role definition, which prevents role confusion and keeps conversations realistic. In the single agent setup, the chatbot just replied with text. But in the multi-agent setup, our frontline agent outputs structured JSON. Each JSON object includes 3 keys. Action: what type of response is needed, query order, escalate, or neutral. Order ID, only present if the customer provides a valid order number. Message, a polite response that can be sent directly if no backend or escalation is required. By forcing structured outputs, we make the chatbot's intent clear and machine readable. This is what enables our orchestrator to intelligently route requests. In the single agent setup, we had a simple chat with customer function. It sent a customer's message to the agent and printed the reply. But now, with multiple agents, we need something more powerful: an orchestrator. This orchestrator decides which agent should respond and how the response should flow back to the customer. The orchestrator starts by receiving the raw customer message. We wrap it into a base message object, marking it as coming from the customer. Then we pass it to the customer service agent. Instead of giving a direct answer, this agent returns a structured JSON response describing what action to take. Once we have the JSON from the customer service agent, the orchestrator's job is to parse it safely. Here we check the action field to decide the next step and pull out the order ID or message if they are present. If the JSON is invalid, we log an error, making sure the system fails gracefully instead of crashing. If the action is query order, we pull out the order ID. The orchestrator then calls the database agent, passing only the raw order number. The database agent checks the dataset and replies with a factual response like order number 1234 for Alice is shipped. Total $75. But we do not send this directly to the customer. Instead, we wrap it into a second message and pass it back to the customer service agent, asking it to rephrase the result politely. This ensures the final response sounds professional, friendly, and customer-ready. If the action is escalate, the orchestrator routes the message directly to the supervisor agent. This agent is trained to show empathy and professionalism. For example, if the customer says, "This is the worst service," the supervisor might respond, "I'm really sorry you had this experience. Let me connect you with a human representative right away." By routing escalations here, we separate emotional handling from factual lookups. If the action is neutral, meaning the customer's message is not about an order and does not need escalation, the orchestrator simply returns the message field from the JSON. This might be a polite acknowledgement or small talk, such as, "Of course, I'm here to help you with your orders anytime." Finally, if we ever receive an unknown action, the orchestrator logs an error so developers can debug the issue. This prevents silent failures and makes the system more reliable. To summarize, the orchestrator is the traffic controller of our multi-agent system. Every message goes first to the customer service agent, which decides what to do. The orchestrator then routes the request to the database agent for facts, to the supervisor agent for escalations, or directly back to the customer for neutral replies. And finally, responses are always rephrased or polished before reaching the customer. This layered design makes the system both flexible and scalable, mimicking how real customer service teams operate. Finally, let's test the multi-agent system with different cases. First, a valid order query. The customer asks about order 1234. The database agent pulls the raw record, and then the customer service agent turns it into a friendly, customer-ready response. Next, an invalid order number. The customer asks about order 9999. The database agent cannot find it, and the customer service agent rephrases that into a polite explanation, suggesting the ID be checked again. Then, a series of frustrated customer complaints. The customer says, "This is the worst service." The supervisor agent takes over here, showing empathy and offering escalation to a human representative. Finally, a disputed delivery. The customer insists order 5678 has not arrived. The database agent confirms it is marked delivered. The customer service agent explains this politely and even offers escalation to the supervisor for unresolved cases. And there you have it.
From a lone AI worker to an orchestrated team. Your next step? Try adding more roles, testing different prompts, or even connecting your agents to live APIs. The possibilities are endless, and today you have just built the foundation.